Okay, so today we're going to finish up this lesson, and we're talking more today about this essential question, what is an imaginary number and how is it useful in solving quadratic equations? We're still doing our modeling standard for mathematical practice. So let's start by defining imaginary numbers, and this is likely something that's brand new for all of you. So there we go. You know that a quadratic equation, x squared equals 1, has two real solutions. So we would know that if we took the square root of both sides, it's got plus or minus 1. The equation x squared equals 0 has one real solution, which is 0. And the equation x squared minus 1 has no real solutions, but it might have something that's a not real solution. So by creating a new type of number called imaginary numbers, mathematicians allowed for solutions of equations like x squared equals negative 1. So we're going to actually solve that. The application for this is typically like electrical engineers use this type of mathematics. That's the place where I've at least seen it before. Imaginary numbers are the square roots of negative numbers. These are numbers that can be written of the form bi, where b is a non-zero real number and I is called the imaginary unit. So I is the imaginary unit and represents negative 1. Some examples of imaginary numbers are as follows. So they give you a whole bunch of examples. We always write the I in front of the radical symbol for clarity, unless it's in this fractional form here. You can write it in the back. Given that I equals negative 1, so this is something you need to learn and memorize. So you know that I is equal to square root of negative 1. You can conclude that I squared is negative 1. Actually, this is probably the better one to remember. So if you see I squared, you know that that's negative 1. You can replace it. Okay? This means that the square of any imaginary number as a negative real number this means that the square of any imaginary number is a negative real number. When squaring an imaginary number, use the power of a product property of exponents. So they're talking about this property right here. All right, so let's look at a few of what's going on here. So we're going to find the square of an imaginary number, and remember that we know that I squared equals negative 1. So I can put a negative 1 in when I have an I squared. So we're just supposed to square this number. So they squared both sides, which means, remember, you can distribute that exponent, and I know it's not that property. It's power of a power property or something like that, but it's really distribution. 5 squared is 25. I squared now gets replaced with negative 1. So, and then 25 times negative 1 is negative 25. I apologize for my voice. I got a little cold. So we're going to square the I squared. So we know that the negative actually goes away because it's really negative 1 squared. We're going to square the I and square the square root of 2. So it's really square root of 2 squared. Actually, let me see how they write it. Let's see if they leave that negative in there. Make sure I'm doing with the... Yep, they leave the negative. So they're putting the negative in front because it's a real number. So we know that the I squared gets replaced with the negative 1. The negative, when we square a negative, it goes positive 1. And the square and the square root basically cancel each other out. They're opposites. So we just get a 2. And then 2 times negative 1 is negative 2. All right, so we're going to reflect a little bit. By definition, I is the square root of negative 1. Does negative 1 have another square root? So the other square root that could possibly exist So what if we had a negative I? So what would happen if I squared that? Well, it would be when I square a negative, I get a positive 1. And when I square I squared, I get negative 1. So it does actually have another square root because it has a negative 1. So we would say that it's yes. And it's because negative I squared. Negative I is also a square root of negative 1. Square, I'm abbreviating a little bit, root of negative 1. Actually, I shouldn't have written because there. Yes, negative I is also square root of negative 1 because squaring negative I also gives negative 1. All right, so we're going to find the square of the imaginary number on our own. So basically, we're going to square these things. So you could rewrite it as negative 2 squared and I squared. We know negative 2 squared is 4. I squared gets replaced with negative 1. 4 times negative 1 is negative 4. We're going to square this. So let's see. The numerator, so it's really the square root of 3 squared over 3 squared times I squared. So square root and square cancel, so I've just got 3. 3 squared is 9. I squared is negative 1. So we're going to have a negative in front. 3 goes into 9 if I was going to reduce this 3 times. So negative 1/3. All right, so the last little explain that we've got to go through here is finding imaginary solutions of simple quadratic equations. Using imaginary numbers in the property below, you can solve simple quadratic equations that do not have real solutions. So now when we were used to be equal to a negative, we can actually solve that now. So for a positive real number, r, the square root of negative r equals I square root of r. For example, if the square root of negative 6 equals I square root of 6. So note that this property effectively extends the product property of square roots to cases where the radicands is negative. The property can be extended to cases where both radicands are negative because I squared equals square root of negative 1 times square root of negative 1, which is this. And then the square root of negative 1 times the square root of negative 1 equals 1, and square root of 1 is 1, which contradicts the fact that I squared equals negative 1. Oh, it cannot be extended to where both radicands are negative. All right, so let's talk about this guy here. All right, so I'm going to step through this, and I'm going to show you my mental trick here, okay? So I know that could be rewritten as negative 1 times 6. And we learned today that I squared equals negative 1. Okay, so I know that I can rewrite that as I squared times 6. Well, I know I can't break up the 6, but I know I can take the square root of I squared. So the square root of I squared is I square root of 6. All right, what they showed us here is a shortcut. So let me explain the shortcut with the same thing, okay? So whenever I see a negative under the radical sign, so I'm going to write that down, you should too. Radical or negative under radical sign. I'm going to pluck my eyes out. Pluck my eyes out. So you can think about it kind of as this kind of eye, right? So pluck my eyes out if it makes you remember it, okay? And you should be getting, now at this point, ask Miss Leva for an eyeball sticker, okay? And put an eyeball sticker right here next to explain 4. So when I see a negative under a radical, I'm going to pluck my eyes out, square root of 6. And I literally get it down to 1 line, okay? All right, so let's go through this. We're going to solve the quadratic equation by taking square roots, allow for imaginary solutions. So you're no longer going to write no real solution or no solution. You can actually find it because you have the I now. So we're going to write the equation. Then they subtracted 12 from both sides. And then they went ahead and took the square root of both sides. You always make sure that you write a plus or a minus in front. And then when we see a negative under a radical, we're going to pluck our eyes out. And then here they split it into the 2 boxes, the square root of 4 and the square root of 3, because 4 is the biggest square number that goes in there. And then they took the square root of 4, which is 2. And then they wrote it exactly the way I would have written it here. So you put the I ends up going in between the in between the whole number and the radical. So plus or minus 2 squared of r, or 2I squared of 3. All right, let's try it again. So we're going to write the equation, and then I'm going to start by subtracting 11 from both sides. So that would give me negative 5 and 4x squared. We're going to divide both sides by 4, so I'm dividing by 4, so I get negative 5/4. And then I'm going to undo by taking the square root of both sides, so I've got negative 5/4 in there still. And I see a negative under a radical. I pluck out my eyes, out, and I still got 5/4. The 5 can't be reduced, but the 4 certainly can. So I've got I square root of 5, and the square root of 4 is 2. So plus or minus I square root of 5 over 2 is fine. You could write it as 5 square root of 2I with the plus or minus in front as well. All right, so you got it. We're going to try it again together a couple more times here. Solve the quadratic equation by taking square root to allow for imaginary solutions. So I'm going to start by subtracting 9. So I've got 1/4 x squared equals negative 9. I'm going to take this and I'm going to multiply both the reciprocal, which would be just a 4. So you've got x squared equals negative 36. We're going to undo the square by taking the square root with a plus or minus in front. We see that negative on the inside. We pluck our eyes out. And the square root of 36 is 6. I probably should have just written it like this to begin with. So 6I. All right, let's try again. So we're going to go ahead and subtract the 3 from both sides. So we've got negative 5x squared equals 7. We're going to divide by negative 5. So 7 divided by negative 5 doesn't matter where the negative floats. I'm going to undo the square by taking the square root of both sides, write a plus or minus out front. We see a negative under a radical. We're going to pluck our eyes out. And I don't think there's any way we could reduce that, so I would just probably leave it exactly like that. So what you're going to do to finish up and getting your points today is you're going to elaborate 13, 14, and 16, and that will finish this up today.